Good morning and good afternoon, everyone. Welcome to this webinar. Nice of you to join. Trace minerals, the forgotten solution to manage the immune system. That is what we're going to talk about today. Alice Hibbert is going to be your presenter for today. But before she's starting, I'm going to say a few words. I'm Chantal Verlin. I'm your host for today. I'm the marketing content specialist for feed additives within Trouw Nutrition. We are more than happy for you to raise all the questions that you have, but please do so via the GoToWebinar panel that you see here in screen. I can see them come in, and I will make sure that after the webinar we will address them in the Q&A session. Webinars will be recorded and available upon request afterwards, and the same goes for handouts. So after this webinar, you will receive an email with an email address, and you can send an email to that email address, and I will make sure that you get the handouts or the recordings. A small disclaimer before we really get started. All the product names and claims within this webinar are very generic, so that can mean that it differs from your own local situation. So please contact your local sales or Trouw or Selco representative to discuss your needs and the options that you have. With no further ado, I'm going to give the floor to Alice, so enjoy the presentation.
Hi everybody, welcome to our webinar today. As Chantal said, my name's Alice Hibbert. I'm the Regional Trace Minerals Specialist in Asia, helping to communicate and educate our local teams on all of the research and development that we do with trace minerals within Trouw Nutrition. So my background is BSc Animal Science, so I specialised in monogastric nutrition, both through my education and my career. And I'm here today to discuss with you some key factors around the way you can manage your trace minerals to help to optimize immune status. So we're going to go through three main topics today. So just a bit about trace mineral nutritional functions and supplementation. Then moving on to a bit of a recap on the immune system and how trace minerals can interact with the immune system, and also just moving into some practical application. Yeah, we should have around 15-20 minutes for questions at the end. So yeah, if you write your questions in the chat box, we should have time to answer them verbally. So please feel free to submit those. Okay, with no further ado. So copper, zinc, and manganese are going to be the key trace minerals I'm going to talk about today. So first of all, on copper, there's several important functions that it has. So for example, helping with the antioxidant defense, with catalyzing certain copper-dependent enzyme reactions, works within macrophages to combat certain infectious agents, formation of collagen and elastin as well. Skin pigmentation, helping of the functioning of the nervous system by being a key in the production of myelin. Next slide. And then also helping with iron metabolism. And I've just listed at the bottom there some key metabolic forms in which the trace mineral is present. So zinc, again, similar, also has a role within the immune system, within the antioxidant defense, which we'll talk about later. It's also a strong signaling molecule, facilitates uptake of more zinc, for example, when it's circulating within the plasma in its albumin form. Also has a very key function in wound healing. So commercially, we see that with helping the animals to heal from different abrasions that may happen, such as foot pad lesions, let's say. And manganese, again, activation of certain enzymes essential for bone and cartilage development, and also the brain and nervous system. Antioxidant activity, of course, and then also synthesis of hormones, so helping to facilitate the reproductive functions. Okay, so one thing to comment on at this point, we've just talked about all of these really important physiological functions which trace minerals take part in. It's worth noting at this point in the presentation, there is 2 different ways we talk about trace minerals when we're supplementing them. The first way is looking at the nutritional levels, so fulfilling the nutritional requirement, which is published with numbers such as the NRC, for example. This is defined by the amount of trace mineral delivered across the intestinal wall. So how much of the trace mineral that the animal is taking in can get into the small intestine to the site of absorption and be absorbed into the bloodstream, at which point the animals can utilize it for all of these functions. We're going to focus on this application today because this is how the animals can utilize trace minerals for immunity. Also, though, worth mentioning, we talk about, in addition, sometimes higher levels of use in the markets where it is permitted. This is actually defined by exceeding the nutritional feeding level, increasing the concentration of trace mineral in the hindgut, especially to a point at which it has a will manage to control the overgrowth of bacteria, which will then have a bigger impact on especially growth and efficiency. So yeah, so we have these 2 different levels, and nutritional levels is how we're going to focus today. So we're focusing on the trace mineral that can be delivered into the bloodstream. So commercially, most feeds will be supplemented, certainly all monogastric feeds in particular, will be supplemented with some form of trace mineral. Now, there is a number of these different trace minerals present in the market of varying quality and efficacy. So you can see I've just included a slide here on the sort of history and the thought process around trace minerals. So when it was realized that the basal raw materials in feed did not contain enough trace mineral to fulfill the animal's requirement, so in the development of modern genetics, it was discovered that by adding the simple inorganic forms of trace minerals such as oxides and sulfate salts, you could actually boost the trace mineral status of the animal and fulfill their requirement. However, it was then identified that these different inorganic sources of trace mineral were particularly unstable, had a big impact, negative impact on feed quality, for example, leading to a reduced bioavailability. So I think quoted in the NRC, absorption coefficient for these sources can be as low as 5 to 10%. Now, that was identified, and there was some innovation within the trace mineral space. So at which point the organic trace minerals and the hydroxy trace minerals were developed. So we can think of these 2 technologies, and the hydroxy trace mineral being the newest, and our own Intellibon brand being the first one to market, as much higher bioavailable sources of trace mineral with much lower levels of reactivity in feed. So essentially, more of the trace mineral you're feeding is in fact able to get to that small intestine for absorption within our nutritional application that I explained earlier. Okay, so just a few examples I'm going to run through now of the feed quality parameters and things to consider with trace mineral sources, because we say that not all trace mineral sources are created equal. So first of all, feeds vitamin stability. So we know, I certainly know, especially with my work in premixes within my career, that vitamins are particularly unstable. And it's something we need to think about. And there's many different raw materials, particularly trace minerals, which can affect the stability of these vitamins. So we did a trial. We looked at 3 groups: control with no supplemented mineral, copper sulfate in the dark line, and we also looked at an Intellibon treatment. Now we stored the premix over time, and we measured the vitamin E recovered. What we found was interesting and not surprising, really. With the copper sulfate, because of its solubility, you see significant reductions in the amount of vitamin E recovered, indicating that there was a degradation effect and reaction going on. So even after 10 days, which is still not a huge amount of time, we had 24% reduction in vitamin E in the premix. And then after about 41 days, we saw then 70% reduction. So essentially, you're having, by considering your trace mineral source, you're can potentially optimize feed quality overall. And vitamins are a huge cost within feed and premix. Now, the hydroxy trace mineral, or the IntelliBond, if you remember my previous slide, we can see that it's quite an interesting effect. This hydroxy trace mineral will in fact not have the same effect on vitamin stability, and you can see 36% more vitamin E found after 10 days and 3 times the amount of stability. And it, because of its insolubility in feed, it will not have any impact on vitamins within the premix. What happens then when we go into the animal, at an animal level? Well, when we tested the then relative amount of vitamin E in the blood, we then saw significantly higher amounts in the IntelliBond treatment compared to the sulfate treatment. So this means that we're seeing feed quality is better by way of available vitamins, and more is being absorbed, which will promote better performance overall, just because of trace mineral source. One other thing to mention, I'm sure a lot of you can spend a lot of money on your phytases, for example. Now, phytate, the anti-nutritional factor, we know has a high affinity for trace minerals. Now, by having a high affinity for trace minerals, within the feed, if the trace mineral is in a soluble source, it may be able to bind to the phytate molecule and prevent the hydrolysis reaction that the phytase has on this phytate to liberate phosphorus. So essentially, if you have a soluble inorganic, especially form of trace mineral, you may start to inhibit this phosphorus release. Now, based on this concept, we did a trial looking at different sources of copper and the relative phosphorus release. You can see we increased the levels of copper just to test the boundaries of this effect, and we saw really interesting results. So with no supplementation, we used this as a baseline. We saw, we've expressed this as a percentage, so we have 100% phosphorus release. Then as we increase the amounts of copper, or the amount of supplemental copper, we start to see this big reduction in phosphorus release, significant reduction. This occurs in copper citrate, copper chloride, really significant, even copper lysine, and also copper sulfate. Essentially, the soluble forms of trace mineral may be having a negative impact on your phytase activity and your relative phosphorus release. Where we don't see this is with the hydroxy trace mineral, because it is extremely insoluble in the feed. So while we do see a small effect, we pushed it up to 500 in this treatment to try and push the boundaries and see what would happen. We do not see the same inhibitory effect as with the rest of the trace mineral sources tested. So you could be getting more out of your phytases by switching your trace mineral source or considering your trace mineral source. Okay, just finally looking at the feed quality, the probiotic stability, I just wanted to mention this because it really demonstrates potentially the reactions that are happening in feed because of different trace mineral source. Now, we have, for example, let's say copper sulfate, zinc sulfate within the feed. What can happen is this sort of dissociation effect because these molecules contain weak ionic bonds. So these products will easily go into solution and cleave to the soluble trace mineral ion, copper and zinc, and separate from its ligand. This soluble trace mineral ion will be very reactive with other things. And we see that in the media, these have an antimicrobial effect, particularly. So we see that the trace minerals are used in hospitals, for example, as a building material to prevent the transmission of bacteria. So essentially, we know that there's this sort of antimicrobial effect. However, what impact is that having on our probiotics in our feed? So we did a trial on this where we tested probiotic plus copper sulfate and probiotic plus IntelliBond, and we did some microbiology. So the copper and probiotics were added to the growth media for 2 hours and then plated. And the resulting inoculum you can see in these graphs. So we had 2 treatments. We had a 50 ppm and 150 ppm of copper, and we can see on almost all counts in the IntelliBond treatment, we have a larger amount of inoculum surviving, meaning that in fact, actually, by utilizing the hydroxy trace mineral, because it has less solubility in feed, it's having less of a negative impact on your probiotics if you use one next to the other. Okay, so I've talked about trace mineral sources. I've talked about the impact on feed quality, but how is this relevant? Well, I'll tell you. So this is relevant because all of these reactions that are happening in the feed are not only impacting your feed quality, but also the bioavailability of your trace mineral source. Because once those soluble trace minerals have interacted with other things in the feed, they may form insoluble complexes and be excreted. So therefore, they may not be available for absorption by the animal. Now, we've done lots of bioavailability trials, and this is just one of them. And you can see here we've looked at 3 different sources. We've looked at IntelliBond, hydroxy, we've looked at sulfate, and we've looked at organics. And we can see that the sulfate by far has the lowest recovery in tibia. We've used zinc here as an example. And you can see, in fact, that the hydroxy and the organic have very similar, if not the same, relative bioavailability. So we can see that because these 2 sources are not reacting with other things in the feed and being soluble, we're getting more trace mineral to the small intestine for absorption, which is very simply put, that is our job as nutritionists, as trace mineral specialists. And worth noting, the bioavailability is what's driving the improvements that we may see in performance using nutritional levels of trace minerals. So this is kind of the mode of action, if you like. Okay, so to the topic of the day. So trace minerals and the immune system. I'm just going to go through a bit of a recap on the immune system itself, and then show you some key areas in which trace minerals can impact the immune function and immune system of animals. Okay, so what is the link here? So we know that nutrition influences a large number of biological processes. It's vital to the immune response, all of these processes, such as gene expression, protein synthesis, signal transduction, and cellular proliferation. I like to think of it as we have 3 key parameters here: the animal's metabolism, the metabolic reactions, the nutrition, and the immune response. Now, all of these 3 factors are totally interlinked, when you influence one, you will influence the others. So we are looking obviously here at nutrition with our trace minerals, and we can have a direct impact both on the immune response and the metabolism, which can then impact each other from there. So nutrition is very much integrated into lots of different parameters like health. Obviously the gut is the first line of defense against different pathogenic bacteria, so it's important to consider. So the other thing that's being picked up more now from the literature is that the requirements of trace mineral for the immune response don't necessarily coincide with those needed for growth. So when I go through some of these factors that require trace minerals, this may have a different level of requirement than those needed for the animals to put on weight, put on carcass, for example, or produce eggs. Okay, immune system recap, slide 1. There's two different types of immunity, if you like. The first one is innate. So there's lots of non-specific defensive mechanisms that have been in place since birth, and we think of this as the first line of defense to defend the animal against any invading pathogen. I've just highlighted, that's it, yeah. I've just highlighted here some of the specialized cells that this system uses. There's a number of different ways this innate immune system actually defends the animal's body. So first of all, we call them phagocystic cells, which means they carry out phagocytosis, which is the production of the reactive oxygen species in order to kill the invading pathogens. So neutrophils and macrophages are examples of two of these. Now, skin. So we have two key structural things here. So the skin, this is one of the first lines of defense against entering pathogens, as well as mucous membranes, which we can include the GI tract within that. And then also the animal can upregulate and downregulate the conditions within its body with factors such as pH and oxygen levels. So that's on the physiological level. Also worth mentioning, and we'll talk about this more later, it's regulated by these substances called cytokines. So these cytokines, as an example, interleukin 1, interleukin 6, and TNF alpha, and they actually allow the immune system to regulate and signal to the animal's body to either initiate or reduce illness. We'll go into that in more detail. Quick update on the adaptive or non-specific. So we have cell-mediated and antibody-mediated immune response. I've included here a little diagram for information about the immune cascade, which is involved in this process. So as the specialized cells mature, they then circulate within lymph nodes in order to respond to pathogens. So we need to think of this as almost like our memory, if you like, or the ability to create the immune memory to prevent pathogenesis in the future. Obviously, this is something that's all in the front of our minds with a discussion about vaccines and the state the world's in right now. So yeah, this is the other side of the immune system. And it's worth noting that specialized cells called dendritic cells can connect the innate and adaptive immune systems, and they interact and work with one another to both rush to the site of infection initially and then create a longer lasting immunity. That's how we need to think of it. Okay, so I talked earlier about reactive oxygen species, ROS. These are produced by our phagocytic cells in order to kill different pathogens which may have entered the animal. Now, this is a good thing. So they're actually produced as a defense mechanism. They're also produced naturally during physiological processes, such as aerobic metabolism, oxidative phosphorylation, and stimulated by macrophages and neutrophils, as I said, in the immune response. However, An excess of these reactive oxygen species can actually induce inflammation and all of the negative impacts of that inflammation, such as DNA damage and cell death. However, the animal's immune system is very clever, and it's developed certain substances to actually prevent these negative impacts of reactive oxygen species, almost mop them up, if you like, to defend the animal against these negative impacts. So you can see I've included some images at the bottom there. Okay, so this is where it gets interesting with trace minerals. So our superoxide dismutase, it's catalyzed by copper, zinc, and manganese. So there's at least three different types of superoxide dismutase I'll talk about now. 1 and 3 is catalyzed by copper and zinc, found in the cytoplasm or in the extracellular regions of the cell. You can see here. But also, there's an important role of manganese in enabling superoxide dismutase to work, which is the principal detoxifying agent. This is because of the position in which the manganese-mediated superoxide dismutase is within the cell. So essentially, the manganese SOD is present in the mitochondria. Now, we know that the mitochondria have a very important role in production of DNA. So by being situated in the mitochondria, they help to have a significant role in reducing DNA damage and oxidative damage, which can have a huge impact on animal health. So increases seen in the literature that increases in manganese especially helps to increase the oxidative protection of the cell because of this upregulation effect with superoxide dismutase in the mitochondria of the cell itself. Okay, we're revisiting our cytokines. I told you we would. So first of all, talking about TNF alpha. This is a strong signaling molecule released by the macrophages. And like I say, everything is a balance. So it indicates disease, inflammation, and fever. And also, interestingly enough, induces adipocytes to secrete leptin. Leptin is an interesting substance which actually tells the animal's brain to stop eating and reduces feed intake. So this then can lead to a depression in lean growth, looking at the literature in swine. But also interesting to note, because we know that feed intake is a very important part of especially the post-weaning challenges. So we have this direct and indirect effect on disease immune status, potentially reducing feed intake. Interleukin-1 is another key cytokine. Again, it signals and it's released by most immune cells and allows for the movement of those immune cells around the body. So it facilitates that. Also signifies to the hypothalamus to induce fever. So these two substances are quite key and are easily measured in the blood samples. So I'm going to talk a bit later about some of our applications and some of the work that we've done. And in fact, these two are used as key measurables to test what the immune status of the animals actually is. Also, I talked about all of these specialist cells. Well, in fact, trace minerals also have an impact, as I said before, in making sure those immune cells can be mobilized and get to the place where they're needed to be to neutralize any pathogenic bacteria, as well as as I said, went into detail, the superoxide dismutase function. Okay, practical application. So, right, so I've talked about all of the science. I hope you're all still with me. I hope you're all still fully interested and awake. But I'm going to now talk about something a little bit more practical. So, we look at the sort of cellular level and the immune level and the metabolic level, and it's one thing, but what do we see on farm? So one of the big challenges of especially pig production is that post-weaning process. So due to social and physical stresses, we see a big negative impact on oxidative status. So what's happening right now, we're having maternal and littermate separation, we're having changes in environment, changes in diet to a less digestible one with no immunoglobulins. And also with commercial units pushing for earlier weaning, to try and turn over and turn around these herds quicker, which only further induces stress. What does this result in? So this results in reduced feed intake, as I mentioned briefly earlier, gut health issues. So there's a developing gut at the moment in post-weaning, which you need to make sure the gut health is optimized, and also can potentially compromise the immune system. So the immune system at this point is already very immature, and we need to facilitate that maturity without too many pathogenic challenges. Also, it's worth noting, piglets have a very high requirement for antioxidant defense when weaning. So essentially, this is because weaning actually increases the oxidative stress and free radical metabolism. So the animals may need higher levels of antioxidants and may require higher levels of trace minerals to help the immune system function in the ways I've explained. So all of this results in, bottom line, reduced growth and reduced profit. So what can we do? I quite like this information. So we've got some quite clever feeders within our research centre in the Netherlands, which can actually check for the feed intake per piglet. And what we did is we simply just looked at the feed intake of a group of piglets, just standard piglets after weaning. What we found was actually quite interesting. So we saw there was a huge variation in feed intake. So for instance, if you're this individual, you've done quite well, you've received a lot of feed, you're probably a more dominant piglet in the litter, whereas this one hasn't actually eaten in 3 days. So this makes a huge impact on trace mineral status, on general nutritional status, and also then gives a huge variability and uniformity of growth later in life. One thing worth noting at this point as well, we've just talked about the feed intake side, and we were noticing with a lot of our piglet data, we were finding that the feed intake was much lower in the sulfate treatment. So we often will compare our hydroxy IntelliBond to other inorganic forms such as sulfates or oxides. Now, what we wanted to do is check the whether is there a preference when you put the two diets side by side for eating one or the other based on trace mineral source. And what we found was quite interesting. So you can see this graph gives you a nice visual on it. The navy blue, the blue section of the bar represents the proportion of feed intake from IntelliBond, and the yellow proportion gives you the amount of feed intake from sulfates. So we can see these stars indicate significant differences. And we can see statistically significant preference for an IntelliBond diet, especially in that period exactly post-weaning. And we think what's happening is that the sulfates, for example, may have a negative taste, and the hydroxy trace mineral, because of all of the things I talked about in my first section, is taste neutral. So therefore, it's not depressing the feed intake at this point. So basically, IntelliBond is returning the feed intake to where it could be without that negative impact of sulfates. Okay, And just to summarize the sort of practical stuff, we need to remember that, in fact, we have a very small window of opportunity with piglet production, especially. And this window of opportunity has a huge impact on the growth at the end. So you can, in fact, actually predict the days to market based on the 10-week weights. So it's very important to optimize all of your both management and nutritional factors. And again, for the reasons I've explained with regards to trace minerals in the immune system, it's important to support that function. So, can trace mineral source affect immune response? So we've done some work, partnered with a university in the US, looking at different treatments of both sulfate and N-telebond trace minerals. So we've got 4 different treatments here. Sorry, there's a slight typo here. We've got 50% sulfate, so 50% of the requirement, 5 copper, 50 zinc, and 16 manganese from sulfate, and 50% of the requirement from Intellibond. We then have actually 100% from Intellibond of the requirement, and 100% from sulfates as well. So essentially we've got 50% and 100% from 2 different sources. We applied both an acute LPS challenge and a chronic LPS challenge, which is applied consistently over time to see if we saw the same impacts. And the results were quite interesting. So essentially, first of all, we looked at the TNF alpha and interleukin 1 in the blood, and we saw, obviously, these are the basal levels before the challenge, and then hour 0, and then in blue we have hour 3. So we in fact see that the highest level of TNF alpha and interleukin 1, which indicates disease, is from the 50% sulfate. So we're seeing that with less trace mineral, or less bioavailable trace mineral, we are not fulfilling the animal's requirements for trace mineral in the immune system as well, which is having a knock-on effect to these the expression of these cytokines. Now, the interesting thing is that when you compare the 100% of the requirement sulfate treatment and the 50% of the requirement Intellibond treatment, we see very similar and comparable results, indicating that with the extra bioavailability found with Intellibond, we're in fact fulfilling the animal's requirement in a much more effective way, and therefore supporting the immune system in a more effective way, which is especially vital after weaning. The other thing then that we see is as we increase our level of trace minerals supplied from Intellibond up to 100%, we then have a further more reduction in recovered TNF alpha and recovered interleukin 1. So this is quite interesting because I think it's picking up on one of the points I made earlier in my presentation about the requirements for growth maybe being separate from the requirements from immunity. Actually, the increasing levels of trace minerals continue to further improve the immune response. So possibly supplementing higher levels can continue this effect, especially when you're optimizing it with a highly bioavailable source. So what do we care about really at the end of the day is the profitability and performance. Well, in fact, actually, our average daily gain is significantly better in our Intellibond treatments, as well as the average daily feed intake, which of course we expected because of our previous work. And also we see the same thing when we give them a chronic challenge. So when we actually apply the challenge in a consistent way over a period of days, we see the same results with expression of TNF alpha in the blood. So these are the levels of TNF-alpha at 0 hours. And we can see that as the level of trace mineral and bioavailable trace mineral increases, we get less and less TNF-alpha consistently across 2 different challenge periods. So, conclusions. Mineral source is key for supporting the immune system in commercial conditions. So when feed intake is low, when there's challenges in the environment, there's going to be a much more poorer oxidative balance. So trace minerals, through their role in superoxide dismutase, and also through their role in mobilizing the immune cells in the innate immune system, are able to further help the immune response. So yes, as I said, minerals are critical for immune function. Telemon minerals are more stable in feed and able to deliver more available trace mineral to the sites of absorption. This is important, and I went through all of these factors at the beginning of this presentation. But bioavailability really is important in this, because remember, it can't have an effect on the immune system unless it's being absorbed into the bloodstream. And as I said, if mineral intake is down, so variations in feed intake, cutting costs, for example, in fact, feeding higher quality minerals with higher bioavailability will help the immune response and help performance as well. So thank you all very much for listening. I appreciate your time. I can hand over to our host, Chantal, to fire some questions at me.
Yes, thank you so much, Alice, for your story. So all feel free to pop in all the questions that you have via your panel. We have around 50 minutes reserved to answer them, so feel free. So I have none yet in, so don't be shy.
Oh,
spend this
obviously
time
my presentation was just very clear, Chantal.
Yeah. So I'm just going to wait just a few minutes to see if there are people coming up with questions. Just to clarify one thing, Alice, can you just really make sure that people understand that this is because you showed only swine data? Can you just explain how this
Yes.
really also counts for poultry as well, just to get that message clear?
Good point. So essentially, yeah, I mean, the reason why we didn't refer to the species necessarily in the title of the presentation is that actually the first sections are not really species specific. So the immune science and the discussion about trace mineral source applies across all species. But we wanted to really push and show you, present to you some of our new information on swine. We in fact are, yes, looking at this information in other species as well, but the immune science is not specific to swine at all, it's across all species.
So we have a question from Douglas, and he's asking if we also have data for ruminants.
I will have to check that. I believe we do, but I'll have to check.
Okay, well,
and can send it on to you. We have your email addresses, so we can.
Yeah, we will make sure that we come back to that one.
I don't know.
Anyone else?
But would Kevin like to weigh in on that? Oh, you're welcome to.
We have Kevin Perryman here as well. That is our trace mineral guru from out of the US.
Yes, you're all very lucky that he's here today with us. Yeah.
Yes, good morning, everyone. And Alice is correct. We do have a few different studies that have a part of their protocol that is designed to look at immune function. And it's exactly as Alice has laid out in her presentation. Immune function is not necessarily all that different from one species to another. So the same cytokines, the same processes that Alice described are present across all the species. And we see that in ruminants as well, where we've looked at it. Alice can provide you more detail on those specific studies. Some of the TRSs, I believe that we have also mentioned that information as well. But the answer is simply that trace minerals do in fact have a direct effect on immune competency in ruminants. And probably, Alice, I would say certainly one of the more detailed studies would be the Cornell transition work, where we looked at sub-Q, subclinical as well as clinical impacts of trace mineral nutrition, source and form on what the effect was in the animals. So, and I can't remember, I believe that's TRS number 50, if I'm not mistaken, that we could go back to, but there are several others that we can cite as well.
Yeah, we can get that over to you, Doug, after this. Douglas, after this, thank you. Thanks,
Thank
Kevin.
you both for answering. Arlette has a question. If you have to make a recommendation to improve the immune system in the piglets with a combination with some of our organic acids, what would your best shot for piglets be?
Combination with organic acids? Well, basically, from a trace mineral point of view, you want to try and maximize your bioavailability. So obviously I outlined all of these different factors. So steering completely away from the soluble inorganic salts is very important. With regards to combinations with other products, what I always say is that whatever you do, you need to make sure it's complementary. So there are other with regards to organic acids, that's normally more of an antimicrobial effect. So that's helping with gut health. But there are other products out there with regards to our products, Presan, which is a nice combination gut health pack and also has a positive impact on immune function and is complementary to the way our nutritional trace mineral products are working. And I think we have some combination information on that too. Yeah. Thanks, Arlette.
Perfect. Thank you so much. Anyone else? A question? We still have enough time. Other questions related to trace minerals besides immune function, maybe?
Yeah. Whilst you've got me and Kevin, feel free to fire away.
Yeah. There's one. Leonidas is asking, are there any studies of Intelibond on the effect of colostrum for piglets?
I don't believe there is, Leonidas. That's an area we're yet to try and discover, I think. But I think in reality, it's I don't believe Intelibond would have an effect on colostrum. But if you think about what colostrum is, what we need to think of these products as is the basis. Okay, so we are enabling the animal's metabolism to function effectively. With regards to colostrum, what that's doing obviously is helping with immune response and things like that. But in order for the reactions to happen to help colostrum work better, you need trace minerals and you need an optimal level of trace minerals. So we need to think of this as really, you know, a high quality nutritional application, which is needed. If you optimize it, it will optimize all of the processes within the body and make them work better. So yeah, that's so we haven't got any direct trials on that, but with piglets and helping the immune response, obviously immune function is important in the response to colostrum, so that may help. Does that answer your question, Leonidas?
Perfect, thank you so much. And then if we have Any comments on the impact of immune system on reproduction?
So essentially, the animal, with regards to reproductive status, what we need to remember is that it is not essential for the animal to stay alive, right? So if we have large amounts of stress, which obviously causes, extra inflammation and oxidative disbalance, one of the things that could be compromised is reproductive performance. So by optimizing the immune function, so giving the animal the building blocks to fight off those reactive oxygen species and enable the immune response most effectively, you're helping to lay those building blocks for better reproduction. So essentially, it's all about how and where energy is partitioned. So yeah, we need to think of the optimal trace minerals as a basis, and then things like reproduction can be optimized on top of that. But obviously, trace minerals have a function directly with reproduction, with sperm production and egg implantation, especially with selenium and things like that. So yeah, there's the kind of direct function as well.
Okay, thank you so much. Yeah. This peek on my screen here. Anyone? We have 8 minutes. And if not, that's also fine. Well, I'm just going to keep on peeking on my screen, but I'm going to close the session slowly. Alice, thank you so much for your presentation.
My
Kevin,
pleasure.
thank you for helping answering some questions. And you, audience, thank you so much for tuning in and listening, and for your interest in this topic. If you have any questions, feel free to reach out. You will receive an email today with an email address you can use. And for Douglas, we will make sure that we send you some of the data for ruminants.
Yeah.
So anytime, reach out to us or to your local sales team for Trial or for Selco, and we will be more than happy to support you in any way we can. So if there aren't any questions anymore, then I'm going to say goodbye. Thank you so much again. Stay safe and have a great day and a great evening.
Thank you.